Lesson 7.4 starts to talk about division, and it will lead us into our whole factoring unit. And essentially what that means is we're sort of going, you could think of it as the reverse direction than all the multiplication work that we've done with polynomials up until this point. So in this second half of the chapter, we're going to start off with resulting trinomial or a simplified, full polynomial, and we're going to be breaking it down into what factors multiply to give you that. That's going to be a really essential concept and topic in order to lead us into eventually solving quadratic equations. So let's talk a little bit about polynomial division. We're going to draw, this first stage right here, we're going to just divide by monomials, and it'll be fairly comfortable, I think, and then we'll lead into the real topic today, which is long division. Okay, so if you have a situation like these examples that you have in front of you right now, 1 through 3, where we are dividing a polynomial by a monomial, right? So this is just a division of a polynomial by a monomial. Then division of a polynomial is completed by dividing each of the terms. So think of it just like we distribute in multiplication, division has to be distributed as well. Okay, so if we're dividing 24x to the third divided by x, 24x to the third plus 6x squared plus 2x, and we want to divide that entire polynomial, right, this whole thing divided by the 3x, then essentially we distribute that, and we make sure that the first term is divided by 3x, the second term is divided by 3x, the third term is divided by 3x, and you're essentially distributing that division just like you would have with multiplication. And then just a few review concepts. We did this back in the fall, but once you have that set up, each term divided by 3x, remember you will divide your coefficients but subtract those exponents. Okay, so when we do that first one, you're looking at 24 divided by 3, which is 8. That's how they got that first term. And then if I have 3x's up here divided by 1x, then you subtract those exponents, you're just going to end up with x to the second power. So 8x squared is your first term. And then you do it here on the second one. 6 divided by 3 is 2, so that's why our second coefficient is 2 there in our answer. X squared divided by x is just x, right? So if I have two factors of x and I divide one out, I still have one left. You can think of it that way. And then on the last term, these x's over itself is going to cancel, and you're just going to have that 2 over 3, which, since it doesn't divide nicely, we'll just leave it as a fraction. Okay? And that's your answer. So that would be your quotient. So let's practice that on a few here. This is fairly comfortable, I think, as long as you're just dividing by a monomial. It's really just distribution. So if we look at number 1, I'm taking the polynomial 48x minus 16. I'm dividing it by 8. So what I'm really going to do is take each term here and distribute that division. I'm going to divide the first term by 8, and I'm going to divide the second term by 8. And when we do that, 48 divided by 8 is 6. The x is still there. And then minus 16 divided by 8 is 2. So that would be our result. And that would be it. That would be done. You could always check it, because you could always, take 8 times 6x minus 2 and see if it doesn't give you the original 48x minus 16. Okay, so you can always check your work by multiplying it back in if you needed to. And you would see, oh yeah, that's 48x and then a negative 16. So it works. Okay, so that's one nice way to check your work. Okay, try numbers 2 and 3. Maybe put a pause on this and check them after you've attempted those and see if you got them right. So go ahead and check your answers on 2 and 3. You should have taken the original polynomial, 9x squared plus 15x, divided each term, so distributed that, and your result should be a negative 3x minus 5. And on number 3, when you divide each term by 6x, your result should have been a negative 2x plus 3. So if that feels comfortable, then you're all set when dividing a polynomial by a monomial. It's just really dividing each term and distributing that operation. Okay? Now, go on to the next page. And for me, it's going to be a blank slate here, because we're just going to do a little bit of quick review. You can do this on the side of your paper or just listen up. But before we go into the next step, I really want to make sure that we are all warmed up on long division, because that's really what the bulk of today's lesson is about, and some of y'all haven't done that in a long time. So let's just do a real quick review problem. I'm going to totally make a problem up here to maybe 243 divided by, let's see, let's divide that by, let's try 9, okay? So if you were doing this problem and you didn't have a calculator, or you're back in elementary school and you needed to just do long division, let's review what those steps would be. So first of all, the number you're dividing, in this case a 243, that would go inside of the division symbol. And the number you're dividing by, in this case a 9, would be on the outside. Okay? So just reviewing the steps for long division, believe me, you're going to need to be warmed up on this. Okay, so when we start to work on this, right, we'll try to see, we'll start on the left and see what's the smallest number that 9 goes into. So if I try to go 9 into 2, I know 9 does not go into 2. You're welcome to put a 0 above that 2 if that helps, or just keep your alignment as you go through. Okay, so but 9 does not go into 2. So we'll try the next number, which would then be considered this 24 right here, right? So if it doesn't go into 2, then we'll try 9 into 24. That does go in. So the question is, 9 times what number would get us close to 24 without going over, right? And that would have to be 2, because I know 9 times 2 is 18. So that goes into 24 pretty well. If I go 3, that's 27. I've gone too big, right? So I'm going to go with the 2. And once you've decided on that 2, notice I lined it up above the 4 there, then we'll start this little cycle, right? So we say, okay, 9 goes into 24 twice, whole times, right? And then I'll come down and say 9 times 2 is 18. And then we would basically find that difference between 24 and 18. I'll review. That would be a 6. Then we bring down the next digit if there is one, and then we start again. Okay? And then we would kind of play the game again and say, okay, how many times does 9 go into 63? Does it go into 63? The answer is yes. How many times? Well, actually, exactly 7 times. And so 9 times 7 is 63. I would do this difference. Okay, I would get a remainder of 0, which means it went unevenly, and the result would be just 27. Okay, if it had not gone unevenly, let's pretend that we had just picked something else and we ended up with a remainder, just as a hypothetical, a remainder of 2. Then just a reminder that I could have, in fact, let's do one like that real quick, just so that we all know what to do there. Let's say I'm doing 16 divided by 3. Okay, I know that doesn't go in. So I say, okay, 3 goes into 16 5 times. 5 times 3 is 15. I find the difference. I have a remainder of 1. So just a reminder, when you have that, then you can write your answer as 5. And then you can take that remainder and put it over the number you divided by. Okay, so that remainder goes as your numerator of your fraction. And then if we were dividing by 3, that would be the denominator. And we would write our remainder as a fraction and leave our answer as a mixed number. Because we're going to do that with polynomials today. Okay? So it would go, we would say, oh, it went in 5 times whole, and then a remainder of 1, and we would put that 1 over the 3, which was our divisor, is what we divided by. Okay? So now that you remember how to do long division, that is what we're going to do, but with polynomials. Okay? Long division of polynomials, I have a step-by-step guide right there. But we're just going to jump right in and just see it in action. And I'm going to focus on the key things that you want to keep in mind as you're working through these, okay? So you have that step-by-step guide if you need it, but let's just go ahead and jump right in and do number 4. So on number 4, you've got 5x plus 4, and you're dividing that by x plus 1. So in this case, I cannot do what we did on 1 through 3, which was just distribute that division, because it's a binomial that we're dividing by. Our divisor is a binomial, so I can't use the method that we did on 1 through 3. I have to use long division. Okay, so we'll set up our long division problem like we did a moment ago. I'm dividing 5x plus 4, so that's going to go inside the division symbol. X plus 1 is going to go on the outside. Now, these are the things to be really careful about. Please listen carefully. As long as you kind of get the hang of this, you should be okay. When you are first going to start playing this long division game, we are only going to focus on the first two terms when we're deciding how many times it is. So for just a moment, not the whole time, but for just a moment, we're just going to focus on those two terms. So my question to you is, x times what gives us 5x? Okay? X times what would give me that 5x? Or in other words, how many times does x go into 5x, right? The answer is 5, right? So I know if I had a 5 times x would give me that 5x. So 5 is our first number that we're going to put up here. Okay? And so notice I didn't take into account the 1 or the 4, at least not yet, okay? Right now, I'm just looking at those leading terms. We talked about how important those leading terms were, so that's what I'm focusing my attention on, okay? So now that we have, okay, you know, if I want to do x times what gives me 5x, it's a 5, cool. Now that I have my 5 up there, though, and we start our little long division cycle, I do need to make sure that I multiply all of my divisor by that 5. So that means that when I come loop around, I'm going to do 5 times x. All right, so let me just show you that real quick. I'm going to do 5 times x, and that's going to be 5x. And I'm also going to be sure to do 5 times 1, which is a 5. Okay? So that's the first thing that's just a little bit different in our long division. You want to make sure that you distribute it to the entire divisor. The next and 100% hands down most common mistake is that when we go to drop our line, typically, remember what we did in the previous slide, we then subtract this. But you got to remember that we're subtracting all of this, which means that we have to distribute that subtraction. Okay? So it's the entire quantity being subtracted. So that was a positive 5x and a positive 5, but when I distribute my subtraction, I'm actually going to subtract this and that. And that's probably the main thing that people forget. Okay, so you got to distribute the subtraction, and then we go ahead and combine straight down. So when that happens, when you combine straight down, these guys should cancel. They should be exact opposites. If you did it right, that term should disappear. And then we have a positive 4 and a negative 5. That's a negative 1. And that is our remainder. How do I know that's my remainder? Well, two ways. First of all, there's nothing else over here for me to bring down, right? There's nothing after the 4. So that's empty space. That was the end of the polynomial, so I cannot keep going. The other way I know that that's the end is that x does not go into negative 1. So if I try to do this again, x times something giving me negative 1 is impossible. Okay, so I know I'm finished. And remember back when a minute ago what I told you about the remainder. This went in times whole, but then we had a remainder of negative 1. So we would still write that as a fraction. I would say it went in 5 times plus, and then I would put my remainder over my divisor. And that is our answer, just like a mixed number, essentially. Okay? That is our solution for that first one. Okay? Now, let's say you wanted to check this answer, just for a moment, okay, to check your work. What we're really saying in this problem is that if I do x plus 1 times 5, I'll almost get that, but then I'll have that negative 1 in there. So the way you check your answer is you ask yourself, okay, if I do that 5 times that x plus 1, and then I subtract the 1, there's that remainder, do I get that original 5x plus 4? That's the question, right? So let's check it. If I do 5x, 5x, 5 times x, 5 times 1 is a 5, and then there's my remainder, and when I combine those, I do get 5x minus 4, which was our original polynomial. So it does work. Okay? Let's try number 5. And let's try that one. And part of what they wanted us to do here was, it said, use polynomial long division to divide, then determine whether the divisor evenly divides into the dividend. In this question, it does not evenly. If there's a remainder, then the answer is no. So let's go ahead and answer that. So no, we did not go in even. We did have a remainder. So our quotient is 5, and then that negative 1 over x plus 1. Okay. So let's try this number 5. So on number 5, I'm going to make a little line here. Let's go ahead and try this one. we are taking 12x minus 8 and dividing it by 3x minus 2. Okay, so remember when I do the first step on this, I'm only going to look at the leading terms. How many times does 3x go into 12x? Or in other words, think of it this way. 3x times what gives me 12x? Well, we know the answer to that is 4. Okay, so 3x times 4 is what gives you 12x, so that's going to be our first quotient number, or number in our answer, right? And then when we loop around, we got to make sure we distribute it. So 4 times 3x is indeed 12x. 4 times negative 2 is a negative 8. I dropped my line, but then do not forget, this is the big thing, that we are subtracting that entire expression. So we're subtracting this, but we're also subtracting that negative 8, which makes it a positive. So you got to make sure you change both signs or all the signs all the way across before you combine. Okay? So if we do that, 12x minus 12x cancels as it should, but negative 8 and positive 8 also cancels, and we have a 0 remainder, which means, yes, this does divide evenly without any remainder at all. The answer is yes, and our solution is 4. And if you tested it and did 4 times 3x minus 2, you should end up with the original 12x minus 8. Okay? Go ahead and try number 6 on your own, and if you feel good about that, then we'll go into the bigger ones. So try number 6, and then check it. Okay, so hopefully that gave you an opportunity to check. I've already set up the problem. If I ask myself 2x times what gives me 10x, I know the answer to that is 5. And then we'll distribute that down. So 5 times 2x is 10x. And then in the second term, 5 times 5 is 25. And then I will drop my line and subtract both terms, so change the sign on both, and then combine straight down. So this cancels, but negative 7 and negative 25 don't cancel. They actually combine and give me a remainder of 32. So in this case, my solution would be 5, and then that 32 over my divisor, what I divided by. So that would look like this. It could look like this, or it could look like that. Either one of those works. They both represent the same thing. But mainly, this does not divide evenly because it did have a remainder, and this would be the actual quotient or answer. Okay? All right, now those were fairly small and simple. Let's go ahead and take it up a notch, right? We start to look at some larger ones. And one of the main things that you want to focus on, or that you want to pay attention to, is when you are setting up this long division, you want to make sure that you give yourselves, set up your polynomial, in standard form. So if they're not in order, that's really going to mess you up. Make sure that your terms are in the proper order when you're setting them. Change the order if you need to, so they're going from high to low. And if you see that there is a term missing, like if you skip from an x squared to a number and there's no x term in the middle, you need to have a 0 placeholder. Okay, so we'll talk a little bit more about that. But just like if I have the number 106, we still write a 0 there to hold the place of the tens place. We're going to need to do that with our polynomials and put that 0 in those places where we might not have a term, so that everything has its place value. Okay, so, but we'll get to that in just a moment. Let's try number 7. So on number 7, they just said use polynomial long division to divide. So we are dividing 15x squared plus 17x plus 4, and that is being divided by 5x plus 1. Okay, so let's play this game like we've talked about. We'll start off by only looking at the leading terms. So when I look at the leading terms, 5x times what gives me 15x squared? So 5x times what gives me 15x squared? Well, the answer to that is 3 and an x. So I know that I would need to do 5 times 3 to get to the 15, and I would know that I would need to do x times x to get the x squared. So I need a 3x in my quotient here. Okay, so we only focus on that in that first step. So I know that a 3x will get the job done here. But once I do that, then I do need to make sure I distribute it when I'm coming back around, meaning that the first product I'm going to get is 3x times 5x, and that's where I'll get my matching 15x squared here, but I will also need to do 3x times 1, and that'll just be another 3x. Okay, so those are my two products. And then I'll make sure that I subtract both of those. So both of these were originally positive, the x squared and the 3x, but then I need to subtract this and subtract that. So you need to make sure you distribute that subtraction. Okay? All right. Now let's combine straight down. So if we did all of that right, these two front terms should cancel. They should be exactly the same if I did that right. And they should just cancel out. In the next column, I have 17x minus 3x. That is 14x. And then, unlike the previous ones, I've got to keep going. I've got a whole nother loop here to do. So I bring down my 4, and guys, then we just play this game again. Okay? Did I do something weird here? I did something weird here. Sorry. Well, that was fun. This should have been a negative. No wonder. That should have been a negative. I apologize. I copied it wrong. So when I do 3x times a negative 1, I do get a negative 3x. Then I subtract that. That's actually going to turn that into a positive. So that looks a lot better. Yeah, so it's a negative 3x originally because it was a negative 1, but then when I subtract a negative, it becomes positive. So I should have a positive 3x. Why does that matter? Because when I combine those, I'll get a 20x, not a 14. Okay? So 20x plus 4. Feel free to pause it and adjust your problem if you need to. And once you have, we'll just start over again. 5x times what gives us 20x? And right now we're only looking at the leading term. So 5x times what gives us 20x? Well, the answer to that is a positive 4. So we write that in our answer. Okay? I know that if I multiply by 4, I'll get 20x. And then we'll distribute it just like we did earlier. So I'll do 4 times the 5x is 20x. But I'll also make sure that I do 4 times a negative 1 is a negative 4. Okay? And then we'll drop a line and we'll subtract these. So I'll subtract this and I'll subtract that, meaning I'll change both signs. Okay? And these x terms will cancel. That means that I did something, right? Because those should. And then 4 plus 4 is 8. And 8 is my remainder, because I'm at the end of the problem. There's no more terms to bring down. 5x does not go into 8. That's my remainder. So my quotient, right, the answer to this division problem is 3x plus 4 plus, and then I'll write my remainder over the binomial I divided by. And that is our solution. That is the quotient to that division problem. Okay? All right, let's get down to number 9. And then if we feel okay with that, we'll do a little bit of area problems. So I'm going to give us a little bit of space here. We'll bump that up. Okay, let's try number 9. So on number 9, check to make sure your terms are in standard form in high to low degree order. Make sure that you're not missing any terms. I have a square, an x, and a constant, so we're good there. Let's go ahead and get started. Negative 4x minus 1 is on the outside. I'm going to copy it correctly. And then 8x squared plus 22x plus 4 is what we're dividing into. And let's start. So you should maybe even pause it if you want to really give it a shot on your own and see how you do, or follow along with me, whichever one you feel more comfortable with. Okay. So the question is negative 4x. What would I need to multiply negative 4x by to get an 8x squared? The answer is a negative 2 and an x, so it's a negative 2x. Okay? I know if I multiply those, it'll give me that exact 8x squared. And then when I now come back around, we'll make sure we distribute that. So negative 2x and negative 4x is indeed an 8, positive 8 squared. I also need to make sure I do negative 2x times a negative 1, which will give us a positive 2x. But then I'll drop my line and I'll subtract, right? I'll change all of the signs across. And then combine, canceling these first ones, and then combining these into a 20x. And then we'll bring down this 4, and we'll play this game again. Negative 4x times what gives me 20x? Well, negative 4 times negative 5. That's what I know I would need. And then I already have 1x, I don't need another one, so it's just negative 5. So if I do negative 5, I think I'm set, but let's find out. Let's go ahead and distribute it. So negative 5 times a negative 4x is a positive 20x. Sure enough, it worked. And then for the second part of that, negative 5 and a negative 1 is a positive 5. But then we drop our line and we change both signs, subtracting the entire row. Okay? And this cancels as it should. And for our remainder, it's going to be a positive 4 and a negative 5, which just leaves us a negative 1. And that's our remainder. So our answer will be the stuff on the top, which is our quotient, and the fraction. So it'll be a negative 2x minus 5. And then you would do plus a negative 1 over that negative 4x minus 1. Or you could have put the negative line in front, but this works just fine. Okay, and that's our answer right there. Negative 2x minus 5 minus 1 over negative 4x minus 1, or plus a negative 1 over negative 4x minus 1. Okay? All right, so let's try a geometry. Of course, you can always try those other ones and then check against the answer key. But if we put this in the context of geometry, really the work is still the same. Okay? So we're going to do 11 together, and then we're going to do 12 in class when you come back. So try number 11 here, though. It tells us here, write an expression that represents the length of the figure. This is kind of like that problem on the handout with the big two-bedroom apartment. And I had not shown you how to do that then, but now you know how to do it. So if you know the area is 8x squared plus 2x minus 15, and they gave you the width, 4x minus 5, then I know I can divide the area, because length times width gives me area. So I divide by that width, it'll give me the length. Okay? So that's the main idea. So just so you know where I'm coming from, area of a rectangle is length times width. So if I wanted to solve for the length, I would just divide both sides. So the length is just going to equal the area divided by the width. So that's what I'm going to set up with my polynomials. I'm going to take that area polynomial and I'm going to divide it by my width, which is the 4x minus 5. Okay? And as long as you know how to set that up, the rest of this is what we've been practicing already. So 4x times what gives me 8x squared? That would be a 2x. Okay? And then we bring that down and multiply it through by our divisor, making sure we distribute through all of it. So 2x and 4x is 8 and x squared. And then 2x and a negative 5 right here, right? So I just did this. And then 2x times that negative 5 is a negative 10x. And then I drop my line and I change all of my signs across so that we're subtracting all those terms. So it's going to be those, and then we can combine straight down. These guys cancel. I get 12x here. I bring down my 15, and we start all over again. Because that's how this game is played. We just start the cycle all over again. 4x times what gives us 12x? Well, 3, right? If I just do 4x times 3, I would end up with that 12x. So that's my next term. And we just do the cycle again. So now I'll multiply that by my divisor. 3 times 4x is 12x. And 3 times negative 5 is a negative 15. But then we're subtracting, so we change all our signs from that second row, and we combine straight down. And these guys cancel as they should, but so does the 15. Negative 15 and positive 15 is 0. We have a 0 remainder, which kind of makes sense because this was the area, so it should have worked out nicely, and it does. So it turns out that the length of our rectangle here is 2x plus 3. And that's our length. And you could always test it. If you do that length times that width, you should end up in that area that they have in the problem at the beginning. Okay, so taking it up a notch, just getting just a little bit bigger, we're going to just do a couple more. Let's do number 13 together, and then we'll finish off with 16. And of course, you can try the other ones, we can discuss them in class, all that jazz. So the only thing that's different about 13 is that your divisor is also a trinomial. That really doesn't change anything. You just got to make sure you distribute to all of that. So we're dividing here 5x squared plus 15x plus 14, and we're taking that and we're dividing it by that x squared plus the 3x plus the 1, okay? And if we go ahead and do that, let me make sure, yeah. Then we're just going to start with the first terms like we have been. X squared times what gives me 5x squared? The answer is 5. And then the main thing is just make sure you distribute that to all of your divisors. So when I come back around, it's going to be 5 times x squared, which gives us a 5x squared. It's going to be 5 times 3x, which is a 15x. And it's going to be a 5 times 1, which is just going to give us a 5. And then we'll drop our line and we'll subtract this, we'll subtract this, we'll subtract that, all the way across. Change those signs, combine straight down. So these guys cancel as they should. Positive 15x and negative 15x also cancel. And then a positive 14 and a negative 5 is just a 9. So that's our remainder. So our quotient or answer here is a 5 plus our remainder of 9 over our entire dividing polynomial, our divisor. That's your answer. Okay, and that's it. And then let's finish off with number 16, and the other ones we can discuss in class, especially we'll do that last word problem together, so you'll have another one of those. So 16, the main reason I want to focus on it is because it gives you a really good example of having to fill in those zeros that I talked about earlier, okay? So if I go ahead and set this up, if I write just x to the third minus 20, I'm going to run into all kinds of problems, guys. I cannot emphasize that enough. So I need to fill in every degree between the very first one and the very last one with 0 terms if needed. Okay, so I am going to start with that x to the third. That's our highest degree. If I don't have an x squared, which is the next degree 2, then I'm just going to write a 0x squared. And if I don't have a regular x term, I'm going to write a 0x term. Okay, and then my constant is that negative 20. And again, like I said a moment ago, that's like me writing the number 5008, right? If I have 5008, I would still put those zeros in the middle to hold the hundredths place and the tenths place. I still have to have those. That's pretty much what I'm doing with this polynomial, okay? All right, so I'm putting in those 0 placeholders. I'm making sure everything is in order from highest degree to lowest degree. And now we can get this game started. We're dividing by x minus 3. Let's go. So how many times does x go into x to the third power? In other words, x times what gives you x to the third? The answer is x squared. So let's start with that. We'll multiply that by our divisor. So x squared times x is x to the third. And x squared times a negative 3 is a negative 3x squared. We'll drop our line. We'll change all signs across the line there. And combine straight down. These guys can and should cancel. And then 0 plus 3 is still just 3x squared. That's what I have there. Bring down this next term. Do it again. X times what gives us 3x squared? X times what gives us 3x squared? That would be times 3x. Okay? So that's our next number in our answer. 3x times x is 3x squared, as it should be. And 3x times a negative 3, that is a negative 9x. Change signs, drop your line, subtract, or combine. Since we already changed the signs, it's just combine. That cancels. 0 plus 9 is 9x. Bring down the next term. Do it again. X times what gives us a 9x? Well, that would be times 9. So we'll do that. 9 times x is 9x. 9 times negative 3 is a negative 27. Then we drop our line and subtract both of those, which changes just the signs, and then combines. The 9x's cancel as they should. Negative 20 and a positive 27 give me just a 7. And that is my remainder, because I don't have any more numbers to bring down, and x does not go into 7. So that is my remainder. So our solution here is x squared plus 3x plus 9, that's the number that we got up here, right? And plus, and then we're going to put our remainder over our divisor. That is the full, complete, accurate, awesome answer for number 16. That is polynomial long division. And when y'all come into class, we'll probably do one that has them out of order just to have a good practice on that, although that's not too big a deal. But that should kind of get you the idea. Feel free to do extra ones and check them against the answer key.